Hey there, Python people. Look, we all know Python is awesome, but have you ever looked at your code and thought, it works, but is it good? Today, we're going to close that gap. We're going to go from code that just functions to code that's a genuine craft.
So let me ask you something, and be honest. You can get a script to run, you can solve the problem, and hey, that's a win. But what's the next level? It's all about going from just functional to truly professional. Writing code that you, or someone else, can look at in 6 months and not get a massive headache.
To help us get there, we're going to use this idea I call the Python Pro Pyramid. Think of it as our roadmap. We're going to start with a solid foundation, build up the main structure, and then climb all the way to the top, to the really powerful advanced stuff. Ready to start climbing? Let's do it.
Okay, first things first. The foundation of our pyramid. These are the absolute non-negotiable basics. You gotta have this stuff down cold before you can build anything great on top of it.
So, let's do a super quick flyby. We've got variables, our little containers for data. Python is dynamically typed, so you don't have to declare what kind of data it is, which is nice. Then you've got your basic data types. You know, numbers, text, true or false, and the operators to work with them. Simple enough, right? This is our solid ground. Let's keep moving up.
All right, time to climb up to the next level, the structure. This is all about how we choose to organize our data. And trust me, getting a grip on Python's built-in data structures, it is an absolute game changer for writing code that's actually effective. First up, the workhorse of Python data structures, the list. These things are just so incredibly flexible. They keep everything in the order you put it in, and you can change them whenever you want. Add things, remove things, swap them around. They're your go-to for most situations.
Next, we have their very close cousin, the tuple. Now, at first glance, they look just like lists, but there is one giant, crucial difference. They are unchangeable, immutable. Once you create a tuple, that's it. It's set in stone. This is fantastic for when you have data that you know should never, ever be altered by accident.
Now, for something a little different, sets. Two things you got to remember about sets. They don't care about order, and every single item in them has to be unique. You try to add a duplicate, it just gets ignored. This makes them ridiculously fast for checking if something exists in a collection. They're also perfect for doing classic math stuff like finding unions and intersections.
And finally, we have the mighty dictionary. With dictionaries, you can forget about item positions. Instead, everything is stored as a key-value pair. You give it a key, it gives you the value back, like instantly. They are an absolute powerhouse for any time you need to map things or store structured data.
So we have our foundation and our structure, but how do we put it all together in a way that doesn't look like a total mess? Well, we need a blueprint, we need rules, and following these rules is what really separates the amateurs from the professionals.
And in the world of Python, that blueprint has a name, PEP 8. Yeah, it's the official style guide, but it's so much more than that. You should think of it as a kind of agreement between all Python developers. When we all follow the same style, our code becomes way easier to read, to debug, and to work on as a team. Following PEP 8 tells other developers, I respect your time. Let's dive into the first rule, which is probably the most famous or infamous rule in all of Python, indentation. It's not just for looks, it's literally part of the syntax.
And the rule here is so simple, but it's non-negotiable. The standard is 4 spaces for every level of indentation, not tabs. Why? Because tabs can look different in different text editors and can totally break your code. Just use 4 spaces, every time. Consistency is key.
All right, rule number 2. You know that feeling when you open a file and you have to scroll sideways forever just to read one line of code? It's the worst. It's a readability nightmare.
So, here's the solution. PEP 8 suggests keeping your lines to about 79 or 80 characters. The whole point is to make it easy to view multiple files side by side on one screen without any of that annoying horizontal scrolling. It forces you to break up long lines in a smart way, which instantly makes your code easier to read.
Rule number 3 is all about making a good first impression. The very top of your script, where you put your imports, a messy import section is a huge red flag to any experienced developer who looks at your code.
You want to aim for absolute clarity here. Put each import on its own line, and then group them. Start with the standard library imports, then third-party libraries, and finally your own local application imports. Oh, and a huge word of warning. Please avoid wildcard imports. From module import star. It just pollutes your namespace and makes it impossible to tell where anything is coming from.
Okay, rule number 4 might be my favorite, because it's all about being kind to your future self. Think about it.
If you have to write a comment to explain what a variable is for, you probably just gave it a bad name. Good naming is its own documentation.
And thankfully, PEP 8 gives us a super clear set of conventions. If it's a function or a variable, use lowercase underscore with underscores. If you're defining a class, use capital words, sometimes called Pascal case. And for constants, values you never intend to change, use all caps with underscores. Follow these, and anyone can look at your code and immediately understand what they're looking at.
All right, we've done it. We've climbed the pyramid and we've reached the top, the apex. This is where we get to play with some of Python's most powerful and elegant features. These are the tools that will truly take your code to the next level.
Let's kick things off with generators. Imagine you need to process a text file that has like a billion lines. If you try to read that whole thing into a list, your computer is toast. It'll run out of memory. A generator is the brilliant solution. It's a special function that yields items one at a time only when you ask for them without ever storing the whole collection in memory.
And you can see it right here in action. The function on the left uses the yield keyword instead of return. That's the secret sauce. When you loop over it, it produces a value, then it literally pauses its own state and just waits for you to ask for the next one. This is memory efficiency at its absolute finest, and it's what makes Python so amazing for handling huge amounts of data.
And finally, let's talk about a neat little tool, Lambda functions. Think of them as tiny, disposable, anonymous functions you can write on a single line. They're perfect for those moments when you need a simple function for a quick task, like sorting or filtering. Instead of going through the whole process of defining a full function with def, you can just whip up a Lambda right where you need it. It's a really concise and elegant tool to have in your back pocket.
And that's our